Hello everyone, I'm Kudo from Suga Company Limited. Today, I'm going to explain the basics of sputtering in an easy-to-understand way. Many people find sputtering difficult because of the complex technical terms. You might not be sure which equipment is best for your needs. As a manufacturer of sputtering system, Suga Company Limited wants to help. In this video, we will explain the principles and mechanism of sputtering. In the second half, we will share tips on how to choose the right system. If you are considering a new setup, please take a look. Let's start with the principles of sputtering deposition. Sputtering uses electromagnetic force to generate plasma around our target material. Positive ions in the plasma collide with the target. This knocks out particles which then deposit onto a substrate to form a thin film. Think of it like throwing a stone into a sandbox. The sand that splashes up and stick to your clothes is like the thin film. This technology has been used in many fields, like semiconductor, since the 1960s. Next, let's look at the two main types of sputtering, DC and RF. DC sputtering uses a direct current power source. It's great for metal targets like aluminum, titanium, and copper. However, it cannot be used for insulating materials because plasma discharge is impossible. RF sputtering uses a high-frequency power source at 13.56 MHz. This allows for both metal and insulating targets, such as silicon oxide. One downside is that RF can sometimes cause ion damage to the substrate surface. At Suga Company Limited, our systems are for research and development, so we primarily offer RF sputtering to give you more material options. Here is the process step by step using SSP1000 sputtering system block diagram. First, place the substrate in the chamber. Next, vacuum the chamber down to 10 to the power of -3 or -4 pascals. This is called base pressure or background. Then, apply voltage to the target and open the gas valve. We raise the pressure to several dozen pascals to start the plasma. After that, we stabilize the pressure at 0.5 pascals. Open the shutter to start deposition. When you reach the target thickness, close the shutter and turn off the power. Finally, stop the gas, vent the chamber to atmospheric pressure, and remove your substrate. Sputtering has 5 big advantages. 1. Stability. You get the same results every time by using the same settings. 2. Strong adhesion. It creates very durable films. 3. Uniformity. Our systems achieve less than 5% variation on a 4-inch wafer. 4. Long target life. A 3 mm target lasts a long time. 4. Versatility. You can create oxides or nitrides or depositing, but there are 5 downsides. 1. It takes time for the vacuum process. 2. The deposition rate is slow, only a few nanometers per minute. 3. Films thicker than 1 micron might peel off due to stress. 4. You cannot use materials with high moisture like plants or biological samples. 5. It's not ideal for complex shapes because it doesn't coat the backside well. Sputtering is used in many research areas: material science for surface study, nanotechnology for nano device, electronics for semiconductors, optics for filter and coatings, energy for solar cells, biotechnology for medical sensors. How do you check a good film? Look at these 6 points: thickness, surface roughness, crystallinity, durability, optical properties, and electronic properties. We use stress profilers or ipsometers to measure thickness. For crystallinity, XRD is used. For durability, we perform abrasion and adhesion tests. Choosing a sputtering system is a big investment. To avoid mistakes, we recommend a trial run. At Suga Company Limited, we offer a test deposition service. Please check the link in the description box below. If this video was helpful, please give us a like and subscribe. Thank you for watching.